Also, why'd you put 111?
That was Monday. This is part of Monday's lesson.
Oh,
Yeah. So you got that plus that. So this isn't as bad as it seems because you can just think of it as like terms, right? So we got positive 4 plus negative 9, which is negative 5. And then you got a positive 3i and a positive 2i, which makes positive 5i. Yeah, makes sense?
Oh yeah, I think we did this.
Okay. So this whole thing is actually called a complex number. It has, all complex numbers have a real number part. And then this is the imaginary part. So together, a real number plus or minus an imaginary number equals a complex number. Okay. However, a lot of teachers will just refer to this as imaginary number, but technically it's a complex number. Yeah. Okay, so adding, not too bad. And then on the test, there will be one of those. There will be one subtracting one. Dun, dun, dun. I'm gonna use the exact same numbers, okay? 4 plus 3i minus, what's harder, adding or subtracting? When do students mess up most of the time?
Subtracting.
Subtracting, and teachers do too. That's why we avoid subtracting if we can. Okay, so 4 minus negative 9 is 13. Normally I would make you like distribute to remove the parentheses or whatever, but I don't think that's necessary. Okay, positive 3 minus positive 2 is positive 1i, but we don't need the 1. So always take a look at the operation. And I think you know what's coming. We got add, subtract.
And then we're stopping there.
Nope. Hey, I'm going to change it up a little bit just because I want some more negatives involved, okay? So instead of plus 2i, I'm going to make it minus 5i. So this is just like the distributive property or FOIL. Some of you learned FOIL, right? So you multiply the first term in each binomial, and you get, let's see, negative 36. We did this, Miko. I remember you asked. We already took notes on this. You guys are killing me right now.
Yeah.
Okay, I just watched the video and I didn't see notes on that. So maybe you guys
4
took notes in class.
times negative 5i is negative 20i. Because I remember distinctly Miko saying, wait, how did that happen? I remember.
Darn.
Okay, positive 3i times negative 9 is negative 27i. And then positive 3i times negative 5i is negative 15i squared. And then you combine like terms, those two. This is where Miko was tripping, which means everybody was probably tripping, but only Miko was brave enough to say it. What does I squared equal? We know, or we're supposed to know, that I squared equals?
1.
Nope.
Negative
Close?
1.
Negative 1. Dun, dun, dun. So this is like negative 15 times negative 1, which is positive 15. And then you combine those two because they're like terms, and you get your answer.
Wait,
Yeah.
I thought negative. Oh, never mind. Okay. It's the square root of -1.
And
right? I equals the square root of -1.
yes, so the two major important concepts. the square root of -1 equals I. And then if you square that and square that, you get -1 equals I squared. Voila. Okay, one more thing. I'm going to show you that the calculator can actually do this. It's bizarre that it can do this. It cannot square root a negative, but it can work with imaginary numbers. So yeah, I don't understand the programming, but crazy, huh? -21 minus 47i, -21 minus 47i. And you always write real number first, imaginary number backwards. If that was an X or any other variable, then you would write that part first. I think that's it for notes. So let me pause the recording. Liz. Okay.
What?
So, let me
Why did
recap.
you stop recording?
So the formula for finding the vertex is x equals -b over 2a. Plug in the numbers. Whatever you get here must be the middle number there. Okay. Now watch this. I'm gonna let you guys in on a little secret. This box is actually a calculator. So now that we know that x is 3, you are going to replace all of these x's with 3's. And watch what I do. I like to call it nay-nay. Watch me nay-nay.
Stop.
Collaborate and listen. Now watch this. If I go up or down, it will tell me the answer to that like a calculator. -1. Everybody see that? So I know the answer is -1. I'm going to put -1 there. Yeah. And then you do 4. And then you do 5. And then you do 2. And you do 1. And because it is symmetrical, that's all quadratic functions are symmetrical. I'll show you a little shortcut. Okay, and I'm gonna go down and it tells me the answer is +1. So that's +1. So all quadratic functions are symmetrical. If this is 1, this one will also be 1. So it's like literally I'm saving you half of the work. Okay. And then you got 2 times 5 squared minus 12 times 5 plus 17. And that is equal to 7. It takes like a split second for it to show up. I don't know why there's that delay, which also means that the y value when x is 1 is also 7. So now we just got to graph these points. So you're going to drag them to their correct location. I always start with the vertex. I don't know why. Watch what happens in a second, guys. And yes, let me tell you, this was not easy to do, to make this. You would not believe the coding required. Look at that. Yeah, what do you think about that? Bam. How many real solutions are there? So if it crosses the x-axis, those are considered real solutions. So how many times does it cross the x-axis or touch the x-axis?
Twice.
Twice. So there are 2 real solutions. And then here, this is just a check button. You're going to type in the original equation. Minus 12x plus 17. Watch what happens when I do plus 15. See how close it is? Now I'm going to do plus 16. It's getting closer. Plus 16.5. See how close that is? 16.9. See how close that is? 16.99. 99999. So 16 would be a little bit off. You guys see that, right? But 17 is perfect. So this is like a check button. if you see just one parabola on your screen, that means you did the table correctly. That means you did the algebra correctly to find the x value of the vertex. Or sometimes this is called the x equals 3 is sometimes called the line of symmetry.
I have a question that you'll hate,
Yeah.
but it's not like a disrespectful question. It's just like I really want to know the answer. When will
Okay.
this be useful in life?
Quadratic functions? Well, you
Yeah, like
saw
what?
that was the whole chapter we just did. Some functions in science are quadratic. I would say though that in your field, medical field, most of the functions that you will deal with will be exponential or logarithmic, Travis. Like when they're talking about when a patient takes medicine and you want to know how long that medicine is going to stay in their system, that's exponential decay.
Okay.
But I can't imagine a doctor ever having to use quadratic. More of a science field. Okay, everybody's going to skip 1B. This is all the 1B is for Tuesday's lesson, okay? So we'll go over this on Tuesday. Then we'll do one more together. Yeah. Let's go with somebody I haven't called on yet today. Honiala. What is the formula for finding the vertex of a quadratic function? And you must sing it to me. Honia, wait, I need to stop recording. So question number 5 is the first problem where you don't get real solutions, you get imaginary solutions. The way you could tell is by looking at the graph and it never crosses the x-axis. So quadratic functions either have one real solution, I showed you an example of that earlier, or it has two real solutions, which is usually the case. And then in this situation, two imaginary solutions because it never crosses. Now, that being said, if you understand how quadratic the pattern is, right? You could literally go to screen 5B and cheat because you could pluck these points out of here and put them into this table, and I literally wouldn't even know. The thing that would look suspicious is you would have no work here. And I'd be like, why didn't you show any work for the vertex? Yeah. You guys want to see me cheat? Want to see me nay? Yeah, watch this.
Sure. Yeah.
2, 3, that's that point right there, right? Everybody agree? That's the vertex. So I could literally go 2, 3. Done. And I didn't do any work. I just looked at the graph. Okay. And then we got another point. Let's see. 1, 4. Everybody see that right there? 1, 4. One, 4. Dun, dun, dun. And so that means if input of 3 will also give us an output of 4. And then maybe I should make you require you to at least once have the work shown in the box. Yeah. At least once for my sanity. So I know that you're not 100% cheating. It's not really cheating. It's using the resources I give you. Anyways, and then we got 0, 7 right there. 0, 7, 0, 7, which means that the last point in the table would be a 4 and a 7. And then this graph should look exactly like that graph. But yeah, at least one time, just so I know you're not 100% cheating, go ahead and show the work at least once, okay? So I understand, or so I know that you understand you have to replace the X values in the function. Yeah.
Yeah.
07 14 2 3 3 4 2 7. Bam. And like I said, that's just for checking. That last button is just for checking. What the? Bro. You guys all just disappeared. Oh, there you are.
I wish.
Stop, I was gonna say that.
So quadratic functions are symmetrical, and you should be able to see that in the graph and in the table. It's the only type of function that does that.
Wait, Mead, how do you figure out if the two solutions are actually imaginary?
Never, if it
Like what
crosses,
what?
how to do it algebraically.
No, just like from the graph.
If it touches the x-axis, the solutions are real.
If it doesn't, then it's imaginary.
Yep. And which means when we solve this problem algebraically on Tuesday, the answers are going to end up being like, here, I'm gonna write it. We're going to get like some bizarre nonsense like x equals 8 plus 3i and x equals negative 8 plus 3i. So after we do all the algebra, that's what's going to end up happening. But if the solutions are real, then it's just going to be a real number, like negative 8, positive 8. Am I still recording? Please tell me I'm not recording. Ah,